I'm going to go through question 4 because that's quite confusing. So let's have a look at the question. The circuit set up like this. The resistor, we're trying to find the value of the resistance. Okay. The voltmeter has a resistance of 2,500 ohms. So I've written that in there. The actual resistance of X is 2,000 ohms. Okay, I've written that there. And the resistance of the ammeter is much smaller. Okay, so the ammeter actually is something like 0 ohms. Okay, we don't worry about the resistance. That one, ideal. What is the reading on the ammeter? Okay, so let's calculate this part first. You can see I've actually started doing this calculation already. Okay, so we need to find the effective resistance of the two components in parallel. So actually, if you do the maths, you'll find that R is equal to 1,111 ohms. No need to round off at this point. Okay, so what will the ammeter reading be? I'll simply use the fact that I is equal to V over R. Okay, what is V? V is 2 volts. So we found that one, and then the resistance is the number we've just calculated. Okay, so that will give you actually a value of 1.8 times 10 to the minus 3 amps. Okay, if you like, you can write that as 1.8 milliamps. Okay, that's the first part. What is the value of the resistance of X that she obtained? Okay, well, Jeanette, doing this experiment, she's going to look at her voltmeter, okay, and she's going to look at her ammeter readings, and she's going to assume that you can find the resistance like that. So she will assume V is equal to IR. I want to rearrange that. Let's put that in terms of R. We're trying to find resistance, aren't we? Resistance is equal to V over I, which will be V is 2 volts, and the value that she's got on her ammeter is 1.8 amps, milliamps, excuse me. Okay, so actually Jeanette thinks that this will give her the value of the resistance, and so that will give you a value of 1100 ohms. Okay, you can see, obviously, this is not the true value. The true value, actually, we know that, we've been told that already, is 2,000 ohms. Okay, this is the value she thinks. Why has she gone wrong? What's happened? Okay, let me have a look over here. The reason is this. Actually, the current coming into the circuit actually splits. And so the ammeter is not measuring the current. Okay, this is not actually measuring the current that passes through X. It's measuring the current that passes through X and V because they recombine first. The two currents, let's call it IX and let's call it IV. So the ammeter is actually reading a combination of IX plus IV. Now, in most situations, IV will be negligible. There's no current flowing through the voltmeter. In this problem, that's not the case. Because the voltmeter resistance is quite similar to the resistance of X, the current will split. And so a large proportion of the current will go through the voltmeter, and so IV has a value. So, in other words, V is reading the correct value. Okay, V is actually the true value here, but the current reading, ammeter reading on A is actually poor. That's not the values. Okay. The correct thing to do, and this is the later part of the question, how can she correct the diagram? Okay, she can correct the circuit by drawing something like this. Okay, why does this work? Because the current comes in now. Yes, the current still splits. Okay, the current still splits. So, but the ammeter is no longer placed here. The ammeter is placed inside this branch, and so the ammeter reading, of course, is actually a true value of the current passing through X. What about V, the voltmeter reading? It's no longer reading the voltage across just the resistor. It's also reading the voltmeter the voltage across the ammeter, excuse me. However, X is very large. The resistance of this is tiny. The resistance of the ammeter is tiny. So this will be insignificant. Okay, this is approximately 0 volts. So the voltmeter actually is giving a very accurate value for the value of Vx. Okay, so this method works very well if X is large. So if X is large, what do I mean by large? Maybe similar to the voltage of the actual voltmeter itself. Now, of course, most examples that's not going to be the case. In most cases, the voltmeter has several thousand ohms, so we don't need to set up like this. Again, going back to this circuit, this is the one that you will normally use, okay, and this is fine. This works best when the resistance of X, okay, is small, which is most questions that we'll be doing. We normally just use a few ohms here and there. A voltmeter, typically, remember, has a resistance of several thousand ohms. Okay, hope this helps.